Hello everyone. So this is our sixth video of data science playlist assignment. So the topic today that we will cover will be naive evaluation. This topic includes multiple classifications regarding naive Bayes classification. Naive Bayes is a probabilistic machine learning algorithm based on Bayes theorem. It assumes that features are dependent of one another, which simplifies computation. Despite its simplicity, naive Bayes often performs well in tasks like spam detection, sentiment analysis, and classification. What is the application of naive Bayes using Python? It is important as it imports required libraries. Python can import required libraries by the syntax using Python. Copy code import Panda in PD form and including Skylearn model selection. And after that, we can import split from Skylearn and Naive Bayes to do so. You can load the data sets. From this demonstration, let's use the iris dataset. We can use the load iris keyword to import it into our main executable code from Skylearn. By this, we can load the dataset into our main program. We can also train the naive Bayes model. We can train the naive Bayes model by this syntax. First, we need to assign it into a variable and using the keyword Gaussian NB. After that, we can give the parameters in that variable dot fit, and in parentheses we can give the arguments. We can also make predictions through this theorem, that is naive Bayes classification theorem. We can also make predictions by using the keyword predict into our syntax. The way we can write our code is, first we can write the basic code including all the libraries and the packages that we want to import. After that, we can predict the test data. We can save it into a variable, assigning it to the model name dot using the keyword predict and passing the data set from which we want to make predictions, or the sample test data from which we want to make the prediction. Fifth is evaluate the model. We can evaluate model by classifying it as a confusion matrix, or checking its accuracy or its F score, or making prediction. With these steps we can evaluate a model, whether it is correct or whether it is suitable for our requirements or not. For that purpose, we can assign the accuracy score. We can to check the accuracy score, we can use the keyword accuracy score and pass the arguments in which we want to check the accuracy of that data. We can store this thing in a variable named accuracy and print it. In such way, we can do so. Now, how to check the output of our naive Bayes prediction? The output will be the model's accuracy, precision recall, F1 score, and a confusion matrix. What are the applications of naive Bayes using R? The applications of naive Bayes using R are: first is load required libraries. Second is load the data set. Third is train the naive Bayes model. Fourth is make predictions. Fifth is evaluate the model. And sixth is output. It is a kind of similar to the one we saw in Python. So let's study it further in more detail. The applications of naive Bayes using R. In R, how we load required libraries and packages into our main program. For this, we can use the keyword library along with the assigned number, that is, for example, E1071, or we can use the word keyword library and then name the package or library we want to evaluate, that is, for example, caret. By this we can evaluate, we can import it into our main program. Now, second, we will see how to load the data set. How we can load a data set to perform multiple operations into it and perform queries in it. For that purpose, we need to load our data set into our main program. For that, we will use iris data set. We need to load the iris data set. For that, we can use the method data in brackets, write iris. Then we can split the data into training and testing sets. We can use set.seed and split the given data into two different sets. One is the training set and second is the testing set. What is training set and testing set? Training set is that set of sample data which is used while modeling, while making of the model, and testing set is that untouched set of samples that we use only at the time of testing. As it is untouched, the model will respond to it in a new manner and individually, right? Now, third point is train the naive Bayes model. We can train the naive Bayes model by using a syntax model and using such uh, less less than and dash symbol along with the keyword naive Bayes, as assigning the species data equal to the data set for the training purpose. This is quite this syntax is quite different from the syntax used in Python, but it works exactly the same way in that does in Python. Now, how to make predictions in R. We can make predictions in R by using the keyword predict and assigning it and passing arguments like the model in which we want to make the prediction and the test data that we want to pass into our model to make predictions. This performing code can be assigned to a variable and store the predicted values and printed accordingly. Fifth point is evaluate the model. We can evaluate our model by creating confusion matrix. Confusion matrix can be created by using the word confusion matrix along with the predictions that we made and the test data from which we made the predictions. We can save it in a variable and print it accordingly. Now, output. The output includes accuracy, precision, recall, FI score, and a confusion matrix. These things we can easily get in our output using a very simple and easy set of code. Conclusion. Naive Bayes is a simple yet effective for many applications. It works well for classification tasks where the assumption of feature independence holds approximately true, such as next data or well separated numerical features. By following these steps, you can easily implement naive Bayes in both Python and R. So by this, we saw applications of naive Bayes using Python and applications of naive Bayes using R. Thank you.